Okay, so today we are going to be talking about dun, da, 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 chemical reactions, chemical equations, and chemical changes. Okay, so first we're going to be talking about chemical equations. So what is a chemical equation? A chemical equation uses a chemical formula, which is this, and symbols, which are little these itself, to describe a chemical reaction and the product it produces. So this is the product. Okay, so this is the chemical reaction right here, and this is the product. So reaction, reactant. The left side of the arrow is always going to be called the reactants. So that's before the chemical reaction starts. This is what you start off with, is the reactants. And then on the right side of the arrow, it yields to the product, and that is after the chemical reaction, this is what you end up with. So the product is just like in multiplication, when you have 2 times 4, the product is 8. So it's the finished product, as I say again. So the first thing we're going to talk about are what are these little letters, actually big letters. So they're actually symbols for the elements. The elements come from the periodic table, and so like just H right here is hydrogen. So capital H is hydrogen, capital C is carbon, capital O is oxygen, capital N, lowercase a, is sodium. So something different about this, as you can probably see, is that it has a lowercase letter, and that's just to that there might be a capital N, which there is, it's nitrogen, but they have to put a lowercase letter after it. But if you put a capital N, capital A, it would be something total different than sodium. So it has to be a lowercase a. So what are these little numbers after the symbols? Those are subscripts. Those are telling us how many atoms are in that symbol or element, same thing. So we can see here there's 2 atoms in this oxygen. So let's move on. How many atoms are in each element? Okay, so I took the same equation that was in this slide. It's the same equation, and we are gonna figure out how many atoms are in each element. Okay, so the first thing that you always want to do is line up the elements from the reactants and the products. So put all sodium, hydrogen, carbon, and oxygen in line, and then put the same, you want sodium and sodium like on the same row, for it's easier to read when you're figuring out if it's balanced or not. So we'll get to that later. So we have sodium and sodium, hydrogen and hydrogen, carbon and carbon, oxygen and oxygen. Okay, but how do we actually find how many atoms are in each element? Okay, so in A is sodium, and there's only one because there's no subscripts after it or anything, so it's just Na, which is 1. Hydrogen, there's 1 right here, 1 right here, so that's 2, plus 3 right here. Let's wait for that to go away. If it will. Well, there's 3 right there, so that's 5. There it is. So there's 5 hydrogens, 1 carbon here, and 2 carbons here. So there's 3 carbons total. And the same thing for oxygen. There's 3 right here and 2 right here, so that's 5 total. And actually, this is a balanced equation, so it's the same amount of atoms for each element, just put in a different way. So we have 1 carbon here and 2 carbons here, which is 3. And I should have done sodium first, but there's 1 sodium right here, 5 hydrogens. So instead of having 1, 2, and then 3 here, it's just 2 are in one element and 3 are here, so there's 5. And then for oxygen, 2 right here, 2 right here. Oh, and I missed one. 1 right there. So there's 5 in oxygen. How to determine how many atoms are in an element? Okay. Key points. If the symbol is by itself with no subscript, that equals as 1. So like we were saying, Na is just by itself, so it's just 1. If the symbol has a subscript right after it, it is the amount of atoms that is in that part of the element. And then I'm going to go on to the next one. The element might be split up, so you have to add them all together. So we're going to put those two together because right here, we'll just use this side because this side is covered when I come down here. So oxygen 2, and then there's just 1 oxygen here, and then oxygen 2 again. So they're all split up. There's 3 different things. 2 of them have subscripts, so there's 2 right here, 2 right here, and this one doesn't have a subscript, so it's just 1, so that equals 5. But they're all split up, so we have to add them all together. If there are multiple symbols together in a subscript at the end of the subscript, ooh, that's a typo. At the end of like the formula only applies to the last symbol. So like right here, actually that's not it, right here. C, capital O, 2. So that's carbon has 1 atom and oxygen actually has 2 because the symbol is right after, before it, and then the subscript is right after it. And then steps is really symbol by symbol, so you just go symbol by symbol, add all the atoms up, and then just use these key points to help you. How can you tell if an equation is balanced? Make a t-chart like I was saying. I'll go back real quick. Make something like this. That will help you and line them all up. Whoops. Then put all the elements down on both sides in the same row of each other for each of the reactants and products. It's easier to read. So like I was saying, if you have products for oxygen first on the reactants and oxygen first on the products, it'll be easier to read when you're trying to figure out if it's balanced. Count how many atoms of each element are in the equation. Do that for the reaction side, then move over to the products. So do both sides. If all the reaction elements match up to the product elements, like oxygen and oxygen, and they have the same number of atoms, it is balanced. If one does not match, so oxygen and oxygen match, hydrogen and hydrogen match, but carbon and carbon on reactants and carbon on products don't match, is unbalanced. So one thing can do something. Demonstrating the law of conservation. Okay, the law of conservation of mass states that the total mass of the reactants before a chemical reaction is the same as the total mass of products after the chemical reaction, which means a balanced equation demonstrates this because in a balanced equation, the reactants' total mass and products' total mass is equal. If the total masses aren't equal, then you have to add coefficients to help balance the total masses of the equation. So I'm going to let y'all read that and like understand it by yourself. Okay, observations. So the element in the equation make up the reactions like NaHCO3 makes sodium bicarbonate, which is baking soda. In the chemical equation, you can see the different formulas it is making to form something new. A chemical reaction has been made when you can see a difference in a formula when you are looking at the equation. So like here, you can tell a difference in the formula because it's different. And then I have a picture right here. And that is it. Thank you so much.